Welcome to Transhumanism Hub. Your bank accounts, your crypto wallets, and even top-secret military files. Today, they're all protected by incredibly complex cryptographic locks, but there's a machine out there that can rip right through them in a matter of minutes. In 2019, Google used one to complete a calculation in just 200 seconds. For context, the most powerful supercomputer at the time would have needed 10,000 years to do the exact same thing. Meet the quantum computer. It's about to completely rewrite the rules of computing power, data security, and even global geopolitics. So, what exactly is it? And why is it both terrifying and absolutely necessary? Let's start with the dead-end traditional computers are currently facing. Moore's law is dying. Single-chip performance has essentially hit a physical brick wall, and right now, we're just brute forcing our way through by stacking more processors. Meanwhile, the sheer volume of data is exploding. The data collected by Google just between 2016 and 2018 exceeded the total amount from all previous periods in human history combined. The explosion of video content is accelerating this even further. Data growth is massively outpacing computing power, and ordinary computers will soon be entirely overwhelmed. This is exactly where quantum computers come in. The core difference lies in the leap from classical bits to qubits. Traditional computers use transistors that act as tiny switches, either on or off, representing zeros and ones. Because a transistor can only be in one state at a time, classical computers can only process one set of data at a time. When faced with mind-boggling complexity, they have no choice but to rely on brute force. Quantum computers play by entirely different rules. They use microscopic particles called qubits as their foundation. A qubit can exist in a superposition of both 0 and 1, much like a spinning coin that is both heads and tails simultaneously. Two classical bits can only express one of four states at a time, but two qubits can represent all four states at once, performing four calculations in a single move. 3 qubits equal 8 states. 4 equals 16. By the time you reach 300 qubits, the amount of information they can process simultaneously is 2 to the power of 300, a number greater than all the atoms in the observable universe. That is the source of the quantum computer's terrifying power. But here's the catch: they aren't magic wands. Every calculation generates a massive ocean of possible results, requiring highly specialized quantum circuits to filter out the actual answer. Plus, they're incredibly specialized. A machine built to crack encryption would be completely useless if you tried to use it for protein folding. On top of that, quantum chips are notoriously fragile. Even the slightest temperature change, vibration, electromagnetic wave, or stray photon can ruin a calculation. The maintenance cost makes traditional supercomputers look cheap. The good news? Scientists are now building quantum chips using ultra-pure silicon-28. By 2023, they managed to drop the concentration of harmful silicon-29 to less than 2 parts per million. And crucially, they can manufacture these using existing semiconductor facilities. In short, the hardware bottleneck is breaking. It's only a matter of time before this computing beast is unleashed. But remember, a machine with godlike computing power is just a giant calculator if it only has a robust body. To truly ignite this revolution, we need to inject it with an equally super-powered soul. This brings us to the ultimate alliance: quantum computing and artificial intelligence. Quantum hardware paired with AI software creates a terrifyingly powerful synergy. Quantum computers supply AI with unfathomable processing power, while AI, in turn, optimizes the incredibly complex quantum circuits and error corrections. We are witnessing the most powerful evolutionary alliance between hardware and software in history. To truly grasp what this means, you have to look at the 3 great eras of computing. Era 1 was analog, calculating with wooden gears and cranks. Era 2 is digital, the world of zeros and ones built on transistors. But now, we are kicking down the door to Era 3, the atomic era. This is a global arms race for quantum supremacy. Whoever builds the first universal quantum computer holds the master key to cracking every military network, banking system, and sovereign database on Earth. And the craziest part? Quantum computers are essentially calculating across parallel universes. It sounds like Marvel, but it's real quantum physics. An electron can exist in multiple places at once. In terms of cybersecurity, this creates the ultimate paradox. Shor's algorithm will completely obliterate the encryption protecting our banks, crypto, and military communications. Yet quantum encryption itself, like quantum key distribution, promises communications that are physically impossible to hack. The ultimate lock and the ultimate key both live in the quantum realm. Now, take a deep breath, because we are diving into the core of this channel: transhumanism. What does quantum computing mean for transhumanism? It's not just about faster calculations. It's about expanding the limits of what human civilization can engineer. Some futurists believe that radically extended lifespans, perhaps even beyond 200 years, may eventually become possible. Whether that future arrives or not, quantum computing could dramatically accelerate the technologies pushing us in that direction. How? 4 major breakthroughs. Step 1. Discovering anti-aging therapies. Simulating complex molecular interactions is one of the hardest computational problems in science. Certain protein folding and drug discovery tasks that overwhelm classical supercomputers may eventually become far more manageable with large-scale quantum computers. That could accelerate the development of customized gene therapies, precision medicine, and entirely new approaches to slowing biological aging. Step 2. Repairing the human body. Medical nanotechnology has existed as a theoretical concept for decades, but designing microscopic repair systems capable of operating inside the human body requires extraordinary computational power and optimization. If such technologies ever become practical, quantum computing could help model and coordinate systems of immense complexity, potentially allowing future medical devices to target plaque buildup, damaged mitochondria, or senescent cells with unprecedented precision. Step 3. Simulating the brain. Scientists still debate whether consciousness itself depends on quantum mechanics, but one thing is clear: the human brain is one of the most complex systems ever discovered. A sufficiently advanced computing system, potentially assisted by quantum computation, might one day simulate neural activity at extraordinary levels of detail. At that point, concepts like mind uploading, digital consciousness, or even transferring aspects of human identity into machines could move from science fiction into the realm of engineering. Step 4. Merging with machines. Training advanced AI systems already demands enormous computational resources. Quantum computing could eventually accelerate certain forms of machine learning and optimization beyond what today's hardware can achieve. And if artificial intelligence begins improving itself faster than humans can naturally adapt, our relationship with machines may fundamentally change. The future may not simply involve humans using AI tools. It could involve a far deeper integration between biological and digital intelligence. That is the promise and the uncertainty at the heart of transhumanism. Without quantum computing, many of these ideas might remain distant speculation. With it, humanity may move closer to technologies that once belonged entirely to science fiction. So, where are we right now? In 1998, the first quantum computer had a grand total of 2 qubits. In 2019, Google hit quantum supremacy with 54 qubits. Experts estimate a truly flawless, universal quantum computer needs about 1 million qubits. But even today, a machine with just 30 reliable, error-free qubits can already crush the world's best supercomputers in very specific tasks. Quantum computers aren't going to replace the smartphone in your pocket or your gaming PC, but they are going to design the hyper-advanced chips inside them. They are going to cure diseases, shatter and forge passwords, and deliver on the impossible promises of transhumanism. Classical computers and quantum computers are not enemies. They are the ultimate partnership. One handling the world we know, the other unlocking the world we are only beginning to understand. And together, they may push humanity further than we ever imagined. If you enjoyed this video, don't forget to like and subscribe. I'll keep bringing you more cutting-edge research in future episodes. See you next time.